when you're trying to find the limit, you don't always have to rely on L'Hopital's rule. So for example, let's say you're trying to find the limit of this as x tends to infinity. So the trick here is to divide everything by x to the power 3. So imagine this as like one thing, imagine this as another thing, imagine this as another one thing here and one thing here. So divide everything by x to the power 3. So divide this by x to the power 3, divide this by x to the power 3, divide this by x to the power 3. Because in effect, what you're doing, you're dividing top and bottom by x to the power 3. That's what you're doing here. But then you can break into this. So divide this by x to the power 3, divide this by x to the power 3, divide this by x to the power 3, and so on. This whole thing here. Well, and then divide this by x to the power 3, divide this by x to the power 3. Then this whole thing here will then become this. Will then become this. So here you can imagine this as like one thing, another thing here, another thing, the number 1, and then this thing here. So as x tends to positive infinity, as x tends to positive infinity, you've got x squared here, you've got x to the power 3. X to the power 3 is going to be bigger than x. Well, as x tends to infinity, this whole thing here will tend towards 0. This thing here will tend towards 0. This thing here will tend towards 0. So in effect, you've got this thing, which is this, divided by 1. So now when you have something divided by 1, it just collapses down to this thing here. You can simplify it to x squared. So now as x tends to infinity, then the whole thing here will tend towards infinity. So as x tends towards infinity, then this whole thing here will tend towards infinity as well. Okay, so another way of looking at this is so the trick that we just used is to divide everything by x to the power 3. So divide this by x to the power 3, divide this by x to the power 3, divide this by x to the power 3, x to the power 3, x to the power 3. So this thing here will disappear, this thing here disappears, this thing here disappears, this thing here becomes 1. This thing here becomes 1. So you've got this thing over 1, and then it collapses down, blah, blah, blah. As x tends towards infinity, then the whole thing heads towards infinity. An alternative way of looking at this, the point here is that you don't always have to rely on L'Hopital's rule. Right? Another alternative way of looking at this is to consider this as being one whole thing, and this being another thing. Now, as x tends to infinity, looking at this numerator, you've got this thing plus this thing plus this thing. As x tends towards infinity, these two terms are negligible in comparison to this term here. If you're just looking at the top bit, so if as x tends to infinity, think about the number, a very, very big number. You see, if you put this into here, put this into here, and these two terms are going to be negligible in comparison to x to the power 5. Okay, if this number is not big enough, think of a bigger number. Now, when you have this number, power it to the power 5, and then here you've got power. When you square it, when you square this number, it's not going to be as big as to the power 5. The point is that if you think of a very, very big number, these two terms are going to be nothing. And then if you consider this here, as x tends to infinity, looking at this and this only, this number 8 here is going to be nothing. So it really boils down to x to the power 5 and then x to the power 3. So as x tends to infinity, as x gets very, very, very big, this whole bubble here, you can consider it as x to the power 5, because these two are not going to be that important. As x gets very, very big, this term, you can forget about this negligible 8 here. So it really becomes this thing here. So then you can evaluate, you can think in your mind in terms of this, and then that becomes x squared. Well, that's just an alternative way of looking at it. Okay.